morning, grade 11s, or good afternoon. What we're going to be doing today is the angle of inclination. Now, what is the angle of inclination? The angle of inclination is always an angle which is measured from the x-axis going anti-clockwise, so until it hits the line, the straight line. So your angle of inclination is an angle from the x-axis or the horizontal axis going anti-clockwise until it hits the straight line. So in this case, we've got an acute angle of inclination, and if we have a negative gradient, then my angle of inclination is from the x-axis, the horizontal axis, going anti-clockwise until it hits the line. That there's your angle of inclination. So it's always from the horizontal going around until it hits the line. Now, how do we find the angle of inclination? Let's have a look at that formula there. We have tan of an angle, the angle of inclination, equals m. Now remember tan from trig, and m stands for gradient. That's right. So let's have a look at how this formula is formed. So if I have a standard straight line here, remember our angle of inclination is going to be that little angle there. Now let's just create a right angled triangle. Now, if I work out the tan of theta, remember from trig, tan is always opposite over adjacent. So that's going to be your opposite. This is going to be your adjacent. And tan of theta is always opposite over adjacent. Now, if we look at it in terms of the Cartesian plane, remember this can also be, this measurement here can also be your y, and this measurement here can also be your x. So now, instead of using the opposite, what about seeing this length here as the y, or the change in y, and this length here as the x, or the change in x? And does that ring any bells? Y over x, changing y over change in x, is just the formula for gradient of a straight line. And that's why tan of the angle of inclination is equal to the gradient. Is a very, very useful combination. It's kind of it's using trig to work with straight lines to find angles. Very, very powerful. Now let's look at how we actually physically find the angle. We now know that the angle of inclination is the angle from the horizontal going around. So now the next little point is, what if I've got my straight line? There's my angle of inclination. It's not there, it's not there, it's not there. It's from the x-axis going around. So we've got our formula, tan of theta equals m. Let's say, for argument's sake, that the gradient of that line is a half. So now if I want to find theta, which is my angle of inclination, we go back to our knowledge of trig, finding angles. You would go shift tan a half in this case. So we would go shift tan a half, and that would in fact give me my angle. Let's quickly work it out. So we're going to go shift tan a half, and we get 26.6 if we round it off to one decimal place, 26.6 degrees. So my angle of inclination here is going to be 26.6 degrees. Okay. But now what if my angle is going to be bigger than 90 degrees? My angle of inclination from the horizontal x-axis going around. So there is my angle of inclination theta. Let's say, for argument's sake, that this gradient here is going to be minus a half, because we know gradients that way is minus a half. So we stick with our formula, tan of theta equals m. In this case, tan of theta equals minus a half. And that makes sense. It ties in with trig. Because remember, angles in the second quadrant, tan is always negative. So tan of an angle in the second quadrant is always negative. Now if we want to find theta here, remember we ignored the minus. So we said we first always found the reference angle. So that is going to be shift tan a half, which is going to be 26.6 degrees. But because it's an angle in the second quadrant, which is an obtuse angle, it's not going to be 26.6, it's going to be 180 minus 26.6 degrees, which gives me my answer. Okay, so keep in mind when we're looking in the second quadrant, negative gradient, it's always going to be 180 minus the acute angle, 180 minus the acute angle. Okay, now the last thing that I need to talk about is, okay, so let's just to recap. Angle of inclination from the horizontal going around can either be acute or obtuse. How do we find it? We use this formula tan of theta equals m. So gradient of the line is very important. The interesting thing is this little formula here is actually on your formula sheet. So it's not a difficult formula, but it's one that is there for you. You don't have to remember it. Then the fourth thing is, sometimes the angles we're looking for are not always from the horizontal around. They're kind of up in the air. So we'll get an example like this. And we'll have a straight line there and a straight line there. And the question will be, what is that angle up there between? Okay, that would be the point of intersection of the two lines. We know how to work that out. We've worked that out previously. But how do we find that angle there? Now, my definition of angle of inclination is that it's from the horizontal up, not from that straight line there. So here we've got to do a little bit of ingenuity. We've got to go back to our basics. What is the angle of inclination from the horizontal around? So now, let's see. We're going to have to introduce a horizontal angle somehow. Okay, now we've got our horizontal. It's just a case of having shifted the x-axis up. Because look, let's look at this scenario here. If that is the angle of inclination there, from the x-axis going around, what's stopping me from just raising the x-axis or raising the horizontal? And in other words, this here could also be seen as the angle of inclination, because why? It's from a horizontal going around. And we know from our knowledge of corresponding angles that those angles are in fact equal. So essentially your angle of inclination is from the horizontal going anti-clockwise. It doesn't have to be the x-axis. It can be any horizontal line really. So now if we look up here, that angle there is going to be equal to that angle there. But anyway, that's fine. So we can find this angle here, because this angle of inclination is going to be from the horizontal going around. So we can find that top little part of theta, okay, because we're looking for the whole one. Now we think, okay, what else can we use? So let's have a look at it. Keeping in mind that the angle of inclination is from the horizontal going around. So we found that angle that's dealing with that line here. But we have a second line in this question here. We have this line here. So we could also find that angle there, because that would be an angle of inclination. So if we can find that angle there, we can also find, it would be the same as that angle there, not so? So now if we can find that red angle, okay, we've got a straight line here. So we've got that angle there. We can find this little one here because it's angles on a straight line. And that angle there is just vertically opposite to that angle there. So there's a few steps involved, but we've now found theta. Let's just recap. We can find that angle there. It's an angle of inclination. Just using our formula tan of theta equals m. Our second step is to find this angle of inclination, just using that same formula there. And then we use our knowledge of geometry, because we know that this is a straight line. So we can find that angle there, angles on a straight line, vertically opposite, so they're the same. So now if I want to find theta, it's just going to be my first angle of inclination plus this angle here, and then I would have found theta. But that's for tomorrow. So in a nutshell, we've done all we need to know about angle of inclination. Quick recap. It's from the horizontal going around. That is the formula we use. If it's in the first quadrant, to find theta, it's shift tan. If it's in the second quadrant, it's shift tan and 180 minus the acute angle. And fourth fact, sometimes we need to find an angle of inclination, which is somewhere off the axes. And then we just need to use the same angle of inclination, the same formula, but we need to change a little bit using our knowledge of geometry in order to find where we're wanting to go. Okay, hope that makes sense, and we'll see you again. Bye. Okay, so now we're going to do some examples, starting with example 9, where we need to determine the inclination of line PQ in each case. So essentially, if that is PQ, we're looking for that angle there, because that would be the angle of inclination. So remember, what we use is we use this fact here, that the tan of any angle is always equal to m, which is the gradient. So in this example here, we first need to go and find the gradient, and there we find it. M is change in y, which is going to be 1 minus 0, over change in x, which is going to be root 3 minus 0, and we get 1 over root 3. So then, once we've got the gradient, we want to find the angle. So we just, on our calculator, we're going to go shift tan 1 over root 3, and we get the angle theta to be 30 degrees. So my angle of inclination in A is going to be 30 degrees. Now let's move across to B over here. Now in B, we need to find the angle of inclination of PQ. Now, there are two ways of seeing this. Okay, PQ is up there, but what we can easily do is we could just extend it. And then my angle of inclination would be that angle there. Or we could visualize it and see it as your x-axis just moving up a bit, and that there would be the angle of inclination. So whichever angle we look and kind of visualize in our heads, we're always looking for the angle which is from the horizontal to the line, and that would be the angle of inclination. So once again, keep in the top of your mind that we're going to use tan of theta equals gradient. So we need to go and first find our gradient, which is not a problem. It's going to be change in y, which is going to be 4 minus 8, over change in x, which is going to be 1 minus 3, which is minus 1. And then we end up with tan theta equal to negative 1. Now remember, because it's negative, it's going to be an angle which is bigger than 90, smaller than 180. So on the calculator, we're going to go shift tan 1, which is going to give us 45 degrees. But because it's in the second quadrant, it's going to be 180 minus 45 degrees, which is going to give us the answer of 135 degrees. So the angle of inclination for number B is going to be 135 degrees. Okay, so here we're going to do another example. Determine the inclination of the straight line 2y plus 3x equals 5, correct to 2 decimal places. So this one we're not going to visualize, we're just going to look at the solution together. So let's start off, because we always remember that we want to go the tan of the angle of inclination, what we're looking for, is equal to m. So the first task to do here is to find out what m, the gradient, is. So in this form here, the straight line is not in standard form. So we need to get it into standard form. We take the 3x across, becomes minus 3x, and we divide by the 2, and our final answer is y equals minus 3 over 2x plus 5 over 2. And then we can pick up immediately from this that our gradient is in fact minus 3 over 2. So we have tan of theta equals minus 3 over 2. And remember to find the angle of inclination, because it's a negative. It's going to be an angle which is bigger than 90. So on the calculator, you're going to go shift tan 3 over 2. You're going to ignore the minus, and you're going to get an answer. And then that 123 degrees is going to be as a result of going 180 degrees minus the acute angle, and we get our answer of 123.69 degrees. Okay, so here we go. We're going to, this is our last example for today. We've got example 11. Determine the equation of a straight line with an inclination of 135 degrees and passing through the point 32. Now this time, we don't have to look for the inclination, we have it. It's 135 degrees, but we're looking for the equation of the straight line, and we have a point that it passes through. So as soon as you have a point that it passes through, you have a possible x and a y that we can substitute into some equation. So let's go back to our equation with inclination. It's always tan of the theta equals m. So here we have m equals tan theta. This time you know the angle of inclination. It's 135 degrees. On your Casio, it's just tan of 135 equals minus 1, which interestingly enough is actually just that line there, which remember cuts that 90 degree exactly in half. It's this, the case of that, oopsie, let's just go back. It's the case of this equation, y equals minus x. It's that line which cuts through the origin. Okay, so now what do we need to do? We need to find the equation of the straight line. So our standard equation of any straight line is y equals mx plus c. We now know m. M is going to be equal to the gradient, which is going to be minus 1x plus c. And now, because we know that this point 32 is an option, we're going to substitute that in place of x and y. So my y is going to be 2, my x is going to be 3. And so now if I solve for this, c is going to be 2 plus 3, which is 5. So the equation here is going to be y equals minus 1x plus 5. And that's the answer. That's the equation of the straight line that we're looking for. Thank you.